All right, let's take a look at one last example here. Find the critical numbers, the intervals of increase and decrease, and the local maximum or minimum, and sketch the graph of f of x is equal to x times 1 minus x to the power of 2 over 5. So, the first thing, we're going to do that domain. And when I'm doing the domain, I'm going to remember that this is the same as x times the fifth root of 1 minus x squared. Because it's not the denominator and a fifth root can be xer, the domain in this case is just going to be x where xer. The second thing, I'm going to derive this. So f prime of x. Now it's a product rule and a change rule. So x and then 2 over 5 bracket 1 minus x to the power of negative 3 over 5 times negative 1 plus 1 minus x to the power of 2 over 5 times 1. When I simplify this, I get negative 2 over 5x and 1 minus x to the power of negative 3 over 5 plus 1 minus x to the power of 2 over 5. I'm going to factor out that fraction. I'm going to factor out the 1 minus x to the negative 3 over 5. And that's going to leave me with negative 2x plus 5, 1 minus x to the power of 1. I'm going to move that negative exponent down to the denominator. So I'm going to wind up getting 5 and then 1 minus x to the power of 3 over 5 in the denominator. And I'm going to simplify that numerator. Negative 2x plus 5 times 1 minus x is going to give me 5 minus 7x. For step 3, we're going to do the critical numbers. And I'm going to pull from the numerator, where 5 minus 7x is equal to 0. I'm going to pull from the denominator, where 5 times 1 minus x to the 3 over 5 is equal to 0. In the numerator, if negative 7x is equal to negative 5, then x is going to equal 5 over 7. In the denominator, I can divide by 5, and 0 is still going to equal 0. I can take the cube root of 0, and it's 0. I can do 0 to the power of 5, and it's still 0, which means that this is just going to be 1 minus x is equal to 0, which means that x is going to equal 1. Then I'm going to do my first derivative test. I have 5 over 7. I have 1. I'm going to pick some test points. So let's use 0, 0.9, and 2, and I'm going to put it into my derivative to see what is taking place here. And I wind up with f prime of x goes from being a positive to a negative to a positive, which means that my f of x is going up, then down, and then up again. And we can see that we have a local max and that we have a local min. I'm going to take this and I'm going to put in to solve for my y values from my original function. So I can say that f of 5 over 7 is equal to 5 over 7 times 1 minus 5 over 7 to the power of 2 over 5, which is going to equal 5 over 7 times 2 over 7 to the power of 2 over 5, which is going to equal 5 over 7 and the fifth root of 4 over 49. I can have f of 0 is equal to 0, and then 1 minus, 1, not 0. F of 1 is equal to 1, and one minus 1 to the power of 2 over 5. Well, 1 minus 1 is 0, which means that this is all just going to equal 0. Therefore, I have a local maximum value of 5 over 7 and the fifth root of 4 over 49, and a local minimum value of 0. If we were to graph this out, then what's it going to look like? I'm going to have my function where it's going to come up and it's going to look like this. Where I'm going to have a maximum here at 5 over 7, and I'm going to have a minimum here at 1. Like it says, notice that at x equals 1, f of x is defined, but f prime of x is undefined. There are 3 cases to consider when determining the behavior of f of x at x is equal to 1. We could have a cusp, we could have a vertical tangent, or we could have just an endpoint. In all 3 of these cases, f prime of x would be undefined at this value.